My original video on this topic, that is basics of pandas and data frames, posted on 17 Jan, got over an hour long. So to make it smaller, I divided that in two parts. This is the second part of the same video. The first part is linked in the description box and in the comment section. In part 1, we covered the portion till missing data. So now we will start with the use of the group by object in a Python data frame, then concatenation and merge functions to join multiple data frames into one, and other pandas operations like finding unique values, sorting a data frame, and pivot tables. Then we will also see how to import, export CSV and Excel files and how to import data from online data sources and repositories. So let's get started. Next, we will move to group by objects. For this, we will create a new data frame. I have the data given here. Let's run this. And we will use this data to create a data frame. So I have this dictionary here. Let's run this, and I will use this to create a data frame. Let's check this data frame. So it has three columns. In the column 1 we have company name, in the column 2 we have person, and in column 3 we have some sales data. So we will use group by method on this data frame. What the group by method does is it groups together rows based off of column names. So for example, we can group the Googles together and use some arithmetic of the remaining columns to get, for example, you want average of Google, we can use group by to group the both Googles together and we'll find the average of this sales column. Similarly for Microsoft and Facebook. So let's group by this data frame. So we have a by parameter here. Axis is 0 by default, 0 or index or 1 or columns. By default it is 0. So we'll pass in the column name for which we want to group data. This will create a group by object. Now you cannot see the data just like that. We have to use an aggregate method of this object. So let's say we want to see the mean of this data. So to return an error, aggregate function fail how mean data type object. So basically if you check the signature here for dot mean, if you check the signature, we have a parameter called numeric only, which is by default given as false. We need to turn this into true, so it will try to find the mean of only the numeric values. Right now it is trying to find the mean of the string as well, and obviously there is no mean of this string, so it was trying to find the mean of this person column. So basically for Google it was trying to find the mean of Sam and Charlie. That makes no sense, so that's why it returned an error. So for this arithmetic function we have to turn this parameter numeric underscore only to true. So what this did here was it grouped the data frame based off of this company column. So all of the same elements got grouped together. So we have three companies here, Facebook, Google and Microsoft, and then it returned mean for the sales. So for Google it was 160, for Microsoft it was 232, and for Facebook it was 296. You can also use this with other aggregate methods. Let's say you want to check the sum, run this and see here once again it tried to find the sum of the this person column, and sum for string is just concatenation. So it glued those two together. It means it has no meaning. If you don't want this column, you can pass in the parameter numeric is equal to true. Numeric underscore only is equal to true, and it will return only the numerical columns. Once again, you can check for max values as well. Now it will return max for string as well, because if you check this data frame here, let's say for FB we have Carl and Sarah. So the way the strings are stored is based on the alphabets, and S will have a higher value than C as an index. So for Max it will return Sarah. For Google it will return Sam, and for Microsoft it will return Vanessa. If you check for min values, it will be the reverse. For FB, for Facebook it will return Carl because C is smaller than S. Then for Google it will return Charlie, and for Microsoft it will return Amy because A is smaller than V as an index. And obviously for the sales column it will return the lesser of the two values. We can also use count here, that will return the count of the values here. And the last one is we can use the describe method with this group by object. So for all three company names, it will provide this descriptive analysis of the data. It will do it obviously only for the numeric column. So for sales count, for sales column, we have count, which was 2. Then we have the mean, we have standard deviation, minimum value, maximum value, 25th percentile, 50 and 75th percentile data here. Now next we will move on to merging, joining and concatenating. These are three ways of combining data frames together. The concatenating first, we have three data frames here. Let's run this and check the data frames. So we have data frame 1, which has 4 columns A, B, C, D and 4 rows ranging from row index ranging from 0 to 3. Then we have DF2, which has the same columns but the row index goes from 4 to 7. And then we have third data frame, which again has the same column but the rows goes from 8 to 11. So let's say we want to glue these data frames together. We want to concatenate this. So we can use the concat method and pass in a list of the data frame names you want to glue together. So what this will do is it will put these data frames one below the other. So we have data from df1, we have data from df2 and then we have data from df3 here. Because all the columns were same, so it will glue one below the other. Now if you check here, we have an axis argument here. Axis was given 0 by default. If you want this to be glued on the columns, you can use this axis parameter and write axis is equal to 1. So pd.concatenate, pass in your data frames as a list and then use axis is equal to 1 and see what it did. Because the index names were not same, it went 0, 1, 2, 3 for all three data frames. It will go below. So this is for first data frame, then the rows will go below that 4, 5, 6, 7 and the third one will go below that 8, 9, 10, 11. When we use axis is equal to 0, which was given by default, we had the same column names A, B, C, D, so it all got glued one below the other. Now for merge, we have two new data frames here called left and right. Let's run this. So on the left we have three columns, key A and B. Key is K0, K1, K2, K3. On the right we have key C and D, K0, K1, K2 and K3. So we have the same key column on both this data frames, and then we have different columns. So this merge function allows us to merge the data frames together rather than gluing it together, which we do with concatenate. Here we can use a column to join the two data frames. So you can use pd.merge and check the signature. We need a left data frame and a right data frame, and then we have an how argument, which is by default given as inner, and then we have on, that is the key we have to pass. So if you check the parameters, we have left and right, and then we have how. This has 5 values: left, right, outer, inner and cross. So left means it will use all of the keys from the left data frame. Right means it will use all of the keys from the right data frame. So if there's any key which is in the left data frame but not in the right, that will get ignored. Outer means union of the both left and right data frames, or all of the keys from both data frame will be used for merging. And inner, outer means the union and inner means the intersection. So only the keys which are present in both data frames would be used, and the other keys would be dropped, other rows would be dropped. And cross creates a Cartesian product. So let's run this. Here we need a left data frame, a right data frame, a how argument and on argument. So for left we have data frames name as left and right, so we'll use left comma right. Then for how, we have inner given by default, so we don't need to use it, but here I am using it to show you. And then on, we have this key column in both data frames. So it used the key column to merge both data frames. We have column A and B from left and C and D from right. For K0 it was A0 B0 and C0 D0 here. And then for K1 it was A1 B1 and C1 D1. Similarly for K2 A2 B2 C2 D2 and K3 A3 B3 C3 D3. And we can use multiple columns as key as well. In that case, you can pass in a list of elements as key 1 and key 2. Column names could be anything. You can pass those as keys. So for merging, we merge based off of a column of the data frame. But if you want to merge based off the index, if the index are different in both data frames, if it was same, you could just use concatenate. But if the index is different, then we can use the join method here. So here we have two data frames with different index. Let's run this and check the data frames. So we have two simple data frames, but the index is K0, K1 and K2 for the left data frame and K0, K2 and K3 for the right data frame. And to use the join method, you can just use a data frame's name and use join method. If you check the signature, we have an other parameter where you have to pass in the other data frame you want to join, and then we have on, which is the key. It is given as none, so it will be index. And how do you want to merge those? So once again, if you check how, we have based on the keys from the left data frame or based on the keys from the right data frame, or you use outer if you want to use all of the keys from both data frame, inner if you want to use only the common keys which are present in both data frame, and then cross will create a Cartesian product. So let's pass in the right data frame, and by default this how is given as left. So by default it will use the keys from the left data frame, which is K0, K1 and K2. If you use left dot join, pass in right data frame, and then how you can pass in the right data frame. So this will use the keys from the right data frame, which is K0, K2 and K3. So it will return the results for that. Or you can use outer, which will use all the keys from both data frame, and because K1 was not present in the right data frame, it will return null for that, and K3 was not present in the left data frame, it will return null for that. Next, we will see some other pandas operations in the data frames. Let's create a data frame for that first. We will use a dictionary for this. Here we will fill in some data for these three columns. A, B, C, D, E, F, G, H, I, and X, Y, Z. So let's run this with three columns. Column 1 has data 1, 2, 3, 4. Column 2 has three digit numbers 444, 555, 666, and then 444 is repeated. And column 3 has strings A, B, C, D, E, F, G, H, I, X, Y, Z. Now let's say we want to check the unique values in this column 3. So as you can see, in this is just a small data frame and we have three unique values here. So you can check the data frame. In the Python we have a unique function for this, unique method for this. In the Python we have a unique method for this. So start typing unique and press tab. It will auto complete and run this. So it will return an array of the unique values in that column. Now what if in place of unique values you want to check how many unique values are there in that column? So for that there are two ways of doing this. One is you have your unique values, this array. You can check the length of this array which will return 3, or you can use an unique method which will return 3 because there are 3 unique values in this column thing. There is another method called value counts where you want both the unique values and the frequency of each value. So you will get to know how many times each of the value occurs in that series. You can use the value counts method, and so it will return those values and the frequency of each value as well. This is a very useful method to check the unique values and how many times they occur in the data frame. Next, we have an apply method which is used to apply functions to a column of a data frame, which is used to apply functions to a column of the data frame. So it will apply that function to each row, each value in the column separately. This is very useful for creating new columns in a data frame when you want to use the existing columns and change the value of that in some way. So here let's define a function called times 2 which takes in a parameter x and returns 2 times of x. So we have this function, and let's say we want to apply this function to each value in column 2. So you can use apply method and pass in your times 2 here. So it will double the value of each cell in this column. You can use inbuilt functions as well. For column 3, which is a string, we can use the apply method to apply len function. Len is a built-in function which is used to check lengths of the string. So it will return 3 if you check the data frame. So column 3 had strings each of length 3, so it returned 3 for each row here. Similarly, for column 2, it double the value of each cell and return that value here. We can also use the apply method with lambda functions. So to give you an example, let's say we have this column 2 here. I want to divide this values in half. We have this column 2. We can use dot apply, and then we can use lambda function here. X turns into x by 2. So let's run this, and it will divide each value by 2. Next, how if you have a data frame, how can you get the column and row index names? Uh, we have this data frame here. Let's say you want to get the column names. You can use column method, and this will return you an index for the column names, which is column 1, 2, and 3 here. Similarly, if you want to check the name of the index, you can use the index method, and it will return you the index, which is a range index starting at 0 and running till 4. So it's basically 0, 1, 2, 3, because 4 is exclusive. If you use range function here, 0 to 4, this will return, convert this to a list, it will return 0 to 3 because 4 is exclusive here. Next, we have sorting a data frame. Let's say you want to sort the data frame based on this column 2. So you can do that using sort underscore values function. Pass in your column 2, and if you check the signature, we have this by, which is index level. So here we are sorting for the column 2, and then axis is 0, so rows are getting sorted. If you want to sort it based on columns, you would have to pass in axis is equal to 1 here, and then we have ascending is equal to true. So data would be arranged from smaller to larger values. This is given true as default. So let's run this and see now that last index 3 has been moved up. How to check for null values? Now if you have a data frame where you want to check for null values, you can use isnull method, and in this data frame it returns false for all the cells because there was no null. But earlier when we created that data frame where there were null values, it would have returned null for 3 of the cells. Similarly, you can also check for NA. Is NA, it will return the same thing here. Next we have pivot table. So for that we will need to create a data frame. I will copy paste some code here. Let's run this. So we had this data dictionary with 4 keys and values given as list for each of the keys, and let's check the data frame here. So here we have this data frame. This is very difficult to read. What pivot table does is, if you know how to use pivot table in the Excel, it will arrange the data based on rows and columns. So it becomes very easy to read. So here we have this pivot table method, and if you check the signature, we have values, index and columns, and an aggregate function, which is by default given as mean. So for values, let's say we want this value. Then we have index and columns. So in index, we want 2 columns to go, A and B. So we'll pass in a list for this. And for columns, we want this column C to be as columns, given as columns. So let's run this and see how this is arranged neatly here. We have A and B as multi-index. So the outside index is bar and foo. For both bar and foo is further divided into 1 and 2 in this inside index. Column is the column C has been divided. The values of column C, there were two values in column C, X and Y. Those have been divided as columns. And now you can see the data for bar 1. For X we have 4 and for Y we have 1. So this turns an data in an Excel or CSV format into a readable table, and it is very useful for easy analysis of data based of index and columns. Next, we will quickly see how to input and output the data from CSV and Excel files. So first we will read data from a CSV file. Let's see. We will read data from CSV and Excel files. So let's create the data frame. Let's name this TF. To read data, we have to use pd.read. As you start typing, press tab, and it will give you a range of options of reading data. So here we have CSV, we have Excel, we have HTML, SQL, XML, and you have range of ways you can read data. So we will use read underscore CSV here. And then if you have the file in the same folder in which you have this Jupyter notebook, you can read it directly using the name. Begin typing and press tab. It will give you the name of the files, CSV files in that folder. So you can do this if the CSV file is in the same folder. If not, you will have to provide the entire path for this. So let's check this. So it will give you the data here. We have this data. You don't really need to use a variable for this, but if you want to use that data, it's better to have a variable name. Now let's say we will write the same data. So if you have a data which you want to export in CSV format, we will use the same data frame. For this we have to underscore, press tab again. So it has all of the same objects from which you can read. You can write to those as well. You can write to CSV file, to Excel file, to HTML, and all of the other files. So here we will use the CSV object and then give a name and run this, and this will create a new CSV file with this table in your folder. Next we will read and write data from an Excel file. Pandas can read and write Excel files. Keep in mind this only imports data. It won't import any formulas or images or macros. And if your Excel file has macros, it may cause read underscore Excel method to crash. So to read the data, use pd.read underscore Excel method. Use the name of the Excel sheet. And for Excel, you will need to provide the sheet name as well. So it will read your data. If you want to store it to a data frame, you can do that. Let's say we have df is equal to 2. We have df2 here. df2 is this data frame. And then for the same data, we can write it to Excel using to underscore Excel method. We'll name it Excel 5. And once again, you can use the sheet name and give any name you want. Let's say sheet 5. Now in Pandas, we can also read the data directly from online sources. For that, you will have to install these three packages. Either you can use conda install or pip install in your command prompt. You can use conda install if you are using anaconda command prompt, or use pip install if you aren't using the Anaconda command prompt. Now to read data from an online source, once again you will use pd.read_html and just pass in the URL. I have a URL of a website from US which has data of all the failed banks. Read this, and what this does is it creates a list. If you check df here, it will return some random stuff. That is because if you check the type, this is a list now, it's not a data frame. So what it does, it takes all of the tables from that website on that web page, it takes all of the tables from that web page and converts those into a list of elements with each element be individual data frames. So you have to index through this list to find your data frame. Here I know that page has only one table, so that first element in the list would be this table I was looking for. And now this is a data frame, you can name it as such. And now if you call df2, it will return you this data frame. See, and you can use this data frame here. So there's a lot of noise outside. I'm going to stop this right here. So in this video, we went through basics of Pandas library and working with a data frame. After you have cleaned and prepared data, the next step is to analyze data. For this, we can use data visualization libraries like matplotlib and seaborn to plot various graphs, which helps us to easily infer information from the raw tabular data. More on this in the next video, which I will link at the end of this video and in the description box too. So that's all for this video. Until next time, see ya.